Hello students, today we are going to study about Introduction to Software Engineering. Now, today's topic is what is software? Okay, what is software? Now, in today we are going to study about detail in software. Now, let's study about history. In 1970, less than 1% of the public could have defined what computer software meant. Today, most professionals and many members of the public at large feel that they understand software. But really, do they? Okay. A textbook definition of software might take the following form. Now, software is first a computer program means instructions that, when executed, provide desired features, function, and performance. Second, software is a data structure that enable the programs to adequately manipulate information. And third, the combination of descriptive information means documentation that describes the operation and use of the programs. Okay. The descriptive information in both hard and soft copy that describe the operation and use of programs. There is no question that more complete definition could be offered for software. But we need more than a formal definition to understand what is software. Now, to gain an understanding of software, it is important to examine the characteristic of software that make it different from other things that human beings build. Software is a logical rather than physical system element. Therefore, software has characteristics that are considerably different than those of hardware. So, the software is a combination of computer programs, data structure, and documents in soft copy as well as hard copy. Now, what are the documentation involved to develop any software? So there are different types of documentation available. What are the documentations? They are specification, means requirement analysis and specification, also called an SRS documentation. Next is formal specification, which contains the main points of the software. Next are the diagrams, context diagram, data flow diagrams, different types of design, uh, sequence diagram, activity diagram, flow charts, ER diagrams, all the diagrams containing in the design part. Next is implementation, means source code. Source code listings, cross reference listings from where we are going to take a reference of the source code. Then comes the testing part, testing data, testing results, test inputs, what are the different outputs, what are the boundary conditions. So the previous documentation are for the developers documentation. Now these are the documentation is used for the client purpose. What are the documents for the clients? First one is user manuals, which contains all the operations, all the functions, all the features of the uh, product or software uh, in detail analysis of any functions in the user manual. Next is system overview, how system is operated, how system will work. All the detailed information about the system working is contained in the system overview. Next is beginner's guide tutorials. If the client have any problems in operating a software, then they come to the tutorials and they know how to operate the any software. The next is reference guide, operational manuals, installation guide, how to install the software in any system. And next is system administration guide, means security, privacy of the data, how they can achieve the privacy, security, networking, database. All these are containing in the system administration guide. Now we are going to study about characteristic of a software. Okay. Now the first characteristic is software is developed or engineered. What is the meaning of it? The meaning of it, it is not manufactured like hardware. We have to develop the software. Although some similarities exist between software development and hardware manufacturing, the two activities are fundamentally different. In both activities, high quality is achieved through good design, but the manufacturing phase or for hardware can introduce quality problems that are non-existent for software. Both activities are dependent on people, but the relationship between people applied and work accomplished is entirely different. Means both activities require the construction of a product, but the approaches are different. Software costs are concentrated in engineering. This means that software projects cannot be managed as if they were manufacturing projects. So the approaches are totally different for software and hardware part. Now the second characteristic is software doesn't wear out. Means the relationship often called bathtub curve indicates that hardware exhibits relatively high failure rates early in its life. These failures are often attributable to design manufacturing defects. Defects are then corrected and failure rates drops to a steady state level for some period of time. As the time passes, however, the failure rate rises again in hardware part. Suffer from the cumulative effects of dust, vibration, abuse, temperature, extremes, and many other environmental maladies. State simply, the hardware begins to wear out. But software is not susceptible to the environmental maladies that cause hardware to wear out. In theory, therefore, the failure rate curve for software should take the form of the idealized curve. So, undiscovered, these are corrected. Undiscovered defects will cause high failure rates early in the life of a program. However, these are corrected and the curve flattens. The idealized curve is gross oversimplification of actual failure models for software. However, the implication is clear. Software doesn't wear out, deteriorate. But it does deteriorate. This seeming contradiction can best be explained by considering the actual curve. During its life, software will undergo change. As changes are made, it is likely that errors will be introduced, causing the failure rate curve to spike. Before the curve can return to the original steady state, failure rate, another change is requested, causing the curve to spike again. Slowly, the minimum failure rate level begins to rise. The software is deteriorating due to change. So, another aspect of wear illustrates the difference between hardware and software. When a hardware component wears out, it is replaceable by a spare part. There are no software spare parts. Every software failure indicates an error in design or in the process through which design was translated into machine executable code. Therefore, software maintenance involves considerably more complexity than hardware maintenance. Now, the third characteristic is although the industry is moving toward component based construction, most software continues to be custom built. What is the meaning of it? Consider the manner in which the control hardware for a computer-based product is designed and built. The design engineer draws a simple schematic of the digital circuitry, does some fundamental analysis to ensure that proper function will be achieved, and then goes to the shelf where catalogs of digital components exist. Each integrated circuit has a part number, a defined and validated function, a well-defined interface, and standard set of integration guidelines. After each component is selected, it can be ordered of the shelf. As an engineering discipline evolves, a collection of standard design components is created. Standard screws and off-the-shelf integrated circuits are only 2000 of standard components that are used by mechanical and electrical engineers as they design new systems. The reusable components have been created so that the engineer can concentrate on the truly innovative elements of a design. For example, the parts that represent something new in the hardware world, component reuse is a natural part of the engineering process. In the software world, it has only begun to be achieved on a broad scale. So, ideas are the building blocks of any ideas. So, a software component should be designed and implemented so that it can be reused in many different programs. Modern reusable components encapsulate both data and the processing that is applied to the data, enabling the software engineer to create new application from reusable parts. For example, today's user interface are built with reusable components that enable the creation of graphics windows, pull-down menus, and a wide variety of interaction mechanisms. The data structure and processing detail required to build the interface are contained within a library of reusable components for interface construction. So these three are the characteristic of the any software. Thank you for listening. And if you have any comment or any question,